Hey guys, today we're talking about bivariate data. So here's just a quick example. We got some bivariate data and we're displaying it in what's known as the scatter plot. So when we collect bivariate data and we want to display it, we most of the time will just do it in a scatter plot like this. And so if we observe this graph and we just try to look at like the important features of the graph itself, we might see well, we've got x-axis and y-axis, and both of these mark one of our two variables. Right? So on the x we got income, and on the y we've got some health index. We're measuring two things at once. We might see that the grid space is filled up with a scatter of points. Now these are our data points, and you can kind of see that associated with every data point we have some value of the independent variable and some value of the dependent variable. And so that's for every single one of these data points. Every single one of these points has an associated income value and an associated health index value. And we can kind of see the trend as income increases. Well, what happens to the health index? It seems that as income increases very loosely, the health index also seems to increase. So we can see some key features from this graph, and from them we can learn a little bit of information about what this data is actually trying to depict. But anyway, some notes. So bivariate essentially means two variables. If I'm collecting bivariate data, I'm collecting two measurements of two variables. So for example, I might be measuring people's height and their weight, or I might be measuring people's test scores and their attendance to school, or I might be measuring the height a plant grows and the water I water it with, the amount of water I water it with. So we're essentially looking for two variables and we're seeing if there's a dependence there. That's why we have an independent and a dependent variable. We're trying to see, does our dependent variable depend on our independent variable? In other words, as my independent variable changes, does my dependent variable change in a pattern? And so we see independent variable goes on x, dependent on y, plot in our data, comes in the form of a sort of scattering of points. We can look at the trend of these points and determine, there is some sort of relationship, or not necessarily a relationship. There's some correlation that we can see. Right, so some different correlations we might see. Here are some examples. Strong positive, weak negative, no correlation, yada yada yada. If we were to describe the trend we see on a scatter plot, this is the method. We remember this acronym, STD, strength, type, direction. So if I'm thinking strength, I'm thinking, is it strong or weak? Okay, so if I look at the difference between this first strong scatter plot and this second weak scatter plot, well, what makes the first plot strong is the fact that my data is very tightly grouped. And so if I drew a line of best fit, you can kind of predict that my data will line up very strongly with my line of best fit. However, if I look at this weak correlation, if I imagine my line of best fit through here, maybe it looks something like this, I can see that my data points are a bit spread out from my line of best fit. So it's kind of a weak correlation, right? It's not necessarily as strong as what we might see in this first graph, where my line of best fit has a lot of data points really, really close and clumped to it. So really indicating to me that there's a strong correlation there. Here we see that it's a weak correlation because our data points are not very clumped around this line of regression. Type. Well, this is just saying, is it a linear regression? Is it a quadratic regression? Is it an exponential regression? For our purposes, we're always going to be thinking linear or non-linear. So if I was looking at the trend of some data and the line of best fit I imagined was a straight line like that, then we're looking at a linear type, a linear correlation. If I had some data that looks something like this, you might think, well, the line of best fit isn't necessarily going to be a line, it might be a curve. So that's a different type of regression. We're going to be focusing mainly on linear regression, lines of best fit. Finally, direction. Is it positive or negative? So in the first graph, we can see that our line of regression has a positive gradient, so we'd say its direction is positive. Here we see our line of best fit is going to have a negative gradient. We'd say it has a negative direction. Okay, some data, if you don't see a trend, that might be because there is no trend. So we might describe it to have no correlation. And finally, some data, you might see it to have a very nice trend, except for certain points that sort of lie outside the main cluster of our data. These are our outliers when we look at scatter plots. Okay, so just a quick example. Here's a set of bivariate data. We've got two variables, x and y. We need to draw a scatter plot of this data, describe the correlation as either positive or negative, describe the correlation as strong or weak, and identify any outliers. Alright, here's how I'm going to tackle this question. I'm going to get my class pad out, go to statistics, and put in all of my data. So okay, so this is all my data. I've put x into list 1, y into list 2. Now if I want to draw a scatter plot, I'll just come up to set graph, make sure only stat graph 1 is ticked. Go setting, type is going to be scatter. X is in list 1, Y is in list 2, that's all correct. Frequency is 1, there's only one of each variable in each of my lists, or in other words, each cell is only got a frequency of 1. And the marking is fine to be square, I don't really need it to be anything in particular, so we'll just leave it as a square. Go set, and come up here, click this button on the top left. Here's our scatter plot. So if we want, we can say calc, regression, linear regression. X is in list 1, Y is in list 2, frequency was 1. Hit OK. We actually get a line of regression, a line of best fit. The equation for it, y is equal to ax plus b, we see. And they give us a, they give us b. So we actually get the line of best fit as an equation. But if we just hit OK, it chucks it in as a graph as well. Oh, as a line as well. So I can immediately see positive. Let's have a look. Is it going to be strong or weak? Well, that looks pretty strong to me. If it was weak, we'd have data points all over the place. So I'd say that's strong. And any outliers? I definitely saw one outlier. This guy down here. We might not. Well, I can put my stylus on that and kind of estimate that point. But if I really want to just know the point accurately, I'll just come up to analysis and hit trace. No, I won't do that. Excuse me. Ooh, I'm going to pause and figure this out. Okay, yeah, no. So I do want to go analysis trace, and that will initially put me onto my line of regression, and I can scale up and down my line of regression using my arrow keys, just like this. But if I wanted to look at my actual scatter points, I would have to use my up or down arrow key, and that would shift me from my line to my points. And then I can just cycle through until I find the point I want. That's x is 13, y is 2. There's my outlier. Okay, all done.